Now, what makes the supply of capital perfectly elastic here? Anybody know? Yeah, but that's part of the driver. But that's actually a hidden parameter. That is, we assumed that we had this additively separable utility function with a fixed rate of time preference. That is, the rate of time preference. Remember, what do we call the rate of, what does economists generally refer to as, what do we mean by the rate of time preference? Yeah, but how do we measure it? In most models, we think about CT, call it CT plus 1. We think about the 45-degree line. We think about the slope of the guy's indifference curve as that point as telling us something about the rate of time preference, right? That's how it is in this model. Because the way you think about it is when you set consumptions equal, the trade-off between consumption at two dates depends by rho. So this model assumes that as we get richer, that rate of time preference stays the same, right? That is, as we get richer, the rate of time preference is the same. What if I modified this model and I made the rate of time preference fall as we got richer? That is, rho, the rate of time preference would depend on how rich I was. Okay? The trade-off between consumption today and consumption tomorrow varied with how rich I was. And let's assume I made it fall as I got richer. What would be true about the long-run supply of capital now? Well, if you made it fall, but more importantly, the long-run supply of capital would now slope down rather than be constant, right? We wouldn't have perfectly elastic supply of capital. We'd have downward sloping long-run supply of capital. Because as the capital stock grew, I'd be getting richer, and as I got richer, I'd be becoming more patient, which means I'd be willing to do more investment, right? So I actually would change this. My interest rate would, my marginal product capital would now end up below where it started. Even though I got more productive, I would accumulate more and more capital to the point where I got down to my new lower rate of time preference, right? It would be now the new lower rho plus delta, not the old level of rho. Okay? All right? So the logic behind the neoclassical growth model, and you can think about it as an adjustment cost model, right? It's an adjustment cost model. It's very much like my other adjustment cost model, where the adjustment cost came because if you want to move capital very quickly, you've got to cut consumption, right? And I had this rising supply price because the more I invest, the more I got to cut consumption. All right. But when I look at a steady state, I don't have to worry about it, right? I mean, it may be that consumption becomes more valuable the less I have, or less valuable in terms of utility the more I have. But the trade-off between today and tomorrow, if consumption is equal, is not affected by that. It's affected by this rate of time preference, right? That is, I'm richer. Maybe that means in utility terms, I value consumption less than I did when I was poorer. But that's true for today and tomorrow. So it doesn't affect this trade-off that's going to drive investment. It's all about the rate of time preference. Okay? All right, so that's basically the idea here. So the logic of the neoclassical growth model is, in this kind of a world, because investment's fundamentally a trade-off between future and current consumption, that there's no real rationale per se that we should have rising supply price in that long run. It all depends. Whether we become more patient or less patient as we get richer. If we get more patient as we get richer, we'll have downward sloping supply. If we get less patient as we get richer, we'll have upward sloping supply. But it doesn't have much to do at all with the curvature of the utility function, right? Because in the steady state, there is no curvature. You're not growing anymore. You're sort of at a constant rate. The curvature is going to tell me the dynamics of how I get there. Okay? Just like that supply function was irrelevant in my adjustment cost model in the long run. The adjustment cost model, right? I didn't have any that I had perfectly elastic supply. I basically assumed it was irrelevant.